This video is about D2CAM. You might ask yourself immediately, what is D2CAM? There's a bit of a story behind it. It all kind of starts back after Christmas when everyone was feeling well rested and thought, hey, I know what would be a good idea. Let's try and do a technical conference, but there's a global pandemic on. So let's try and do a virtual technical conference. And what we could do is we could try and make packages and talk about things and really edit them down to keep people's attention. But we could then try and film things in our Bristol studio and link people in using SRT and do all of these really good, fun, dynamic things and try and reach out on Twitter and by email and social media to get questions in to put to people. And so, this idea came about and we discussed it and I spoke to Jan and Daniela and we talked about what we would do. So we started having a technical conversation about, okay, well, what would we need to do in our studio to make this happen? We probably needed some more cameras, we said to Jan, and of course it's very dangerous to suggest buying things to Jan because he likes to double down. So he came straight back to us and said, well, what if we recorded on iPads? iPads have got awesome optics these days, and with the increased optics, we can do so much more. And we could use this as the excuse to finally get around to embedding the Daniel 2 codec into Apple devices and Android devices. So I don't know why, we just didn't move fast enough perhaps, but the next thing we know, me and Jason had agreed that we'd check out how they looked in the studio and maybe think about building something. So D2CAM was born, the Daniel 2 codec-based camera for iOS devices. And the story carries on from there. We had to try and actually make it work. We had to work out how we would transport this stuff over the network. We had to figure out a lot of different moving parts. And this video is the story of what did we do and how did we do that? And where might we go from here with that? So let's talk about the Daniel 2 camera D2CAM app that we're using right now. And in actual fact, I'm using to record this in our studio right now. Well, first of all, we looked around at the state of the art, at what was available. We looked at the NDI app, we looked at various other streaming apps, and none of them quite did what we wanted. None of them targeted broadcasters specifically. None of them had features that broadcasters might hope for, such as 422 color spaces, iframe codecs that would be easier to edit and more resistant to errors. Having looked at these apps and then having looked at the physical hardware, we realized that with the newest iPads, we can plug in USB-C and USB-C Ethernet. So we can actually get 5 gigabits of data out of an iPad these days with the new iPad Pros and the iPad Airs that we're shooting on. And we can then transfer at really high data rates to maximize the quality of what's going on. So we kind of figured out the physical hardware and we figured out that we were going to have to write some software. And then we thought, well, what will we really want to get out of this technical conference? So what we're going to do now is we're going to cut to a video that I filmed with Jason a few days ago, where we take you through what we've actually done in the studio. We kind of spin the camera around and catch what we've got set up. It's quite a modest setup. We're not professional broadcasters ourselves. We just build the tools for professional broadcasters. And we want you to see how we've set this up and how we've kind of lived in what might be some of your worlds for a few weeks while we've staged this event. So we're here in the studio area with the iPads that we've chosen to use as our cameras. So running on here is the D2CAM app. So we've got a tighter and a wider shot from 2 iPads, and they're running our app on here. Now, we don't want to trust Wi-Fi. Unfortunately, modern iPads have USB-C connectors. So we have just some little USB-C connectors that take us to a hub, and then we can power that hub as well as then connect. In this case, we've actually gone to the trouble of putting 5 gigabit USB-C Ethernet adapters on there. So we actually have enough headroom to do some testing with 4K moving forwards. So we've built these little setups. These are just a mount with a case hacked off on to act as our little stand. So we're actually now really happy. We've got our IP cameras that we've built and put in place here. And the app just sits and runs for days and days and days, outputting in the Daniel 2 codec our output stream, which we can then pick up on our servers and use in our input. So we've been really, really happy with the results we've got from these. And the great thing is it's a really simple setup. So we can just pop these iPads off and use them as iPads for the rest of the time we might want to, giving them a second life. And then we can just drop them into the studio and plug in the USB-C hub, and they're ready to go and be our cameras again. So The studio setup is really simple. We've been very pleased with the way that the lenses on the iPad Pro and the iPad Air have given a great deal of quality, but also a decent light pickup. So while we've got quite a lot of lights in here, the quality we're getting from the sensors is really beautiful. And as we then feed that into our Air engine, it looks as good as any of the broadcast cameras we've had in previously. So with this setup, this is how we've actually filmed and will be live streaming and are live streaming the event.
So to have a look behind the scenes, when we decided to do the stream from our studio, we had the usual issues to solve, like how we're going to get our remote contributors in, what are we going to use to cut between the cameras in the studio and the packages, as well as all the audio and talkback to resolve. So let's have a look at what we did. Audio was simply dealt with by using the Rodecaster, so all the local microphones can come in there. That can also deal with the mix minus and clean feeds to go back for talkback and for people's earpieces. As far as cutting the streams are concerned, we could have used Synergy Live, but because we wanted to show interoperability with third parties, we decided to go with OBS, a very popular streaming software that's available, downloadable free of charge. So we thought we would show you and use the OBS. But what about interconnecting between the different sites? How do we get our remote people in? Well, we have the Synergy encode at their home. That sends SRT across the internet. That's landing here. And then again, to show interoperability, we're flipping that to NDI and then bringing the NDI into OBS so that we can compile it all together before finally sending it out to our distribution.
So that gave you an idea of what we've got in the studio and what Jason's doing and how we're trying to show interoperability as much as possible, because that's really important to us. Let's talk a little bit about what the D2CAM actually is and how that's built. So, cue the infographic. So at the core of the D2CAM app is the Daniel 2 codec. Now you'll have heard us talk about this before. It's our incredibly powerful, fast, optimized codec that's designed for multi-threaded cores, parallel compression on GPU and in CPU. So if we look around what this app's built from, you'll see that at the center we've got the codec, and we've connected that up to the AV Foundation framework that's available to us in iOS, so that we can access the brilliant optics on iPhones and on iPads to access frames and compress them instead of going to the onboard hardware to our software-based Daniel 2 encoder. Now, the bit rates shoot right up with Daniel 2. As we've mentioned before in previous things, you really need to remember to compare the Daniel 2 codec with codecs such as AVCI 100, ProRes, DNX HD. It's these kind of codecs it competes with. If you're recording or streaming with Daniel 2, you've got to be prepared for a lot more bit rate than you would be getting with H.264 and H.265. But on the plus side, the quality can go much, much higher, and we can keep many features in there that you would lose normally using the onboard chips. So surrounding this core app, we've got a basic application framework at the moment that lets us live stream this. And here we bolt on the SRT network library. We like the SRT network library because it gives us a load of features that we get that aren't available if we just go straight to the native network. One of the benefits of using the SRT library is not only do we get error recovery if we have network problems, we can also retransmit the packets that go missing. On top of that, we have a great deal of visibility of what the link quality is like, and we'll come back to some details about that later. Continuing our tour of what's here, obviously we've now finished capturing the video, recording it into a codec, and we've gone into those USB-C hubs now with using the SRT network stack, and we enter into our network world here. So in the studio, we've got a Synergy Air engine ready to catch the output from these iPads. And we can use that Air engine then to restream it back out as multicast, compress it to H.264, or in the case of what we're demonstrating here, we actually flip it in real time to NDI. And that allows the OBS system that Jason's working on right now to pick up the output of these cameras and record that and manipulate that and work with that. And NDI in this case was a great choice for a low latency, network optimized codec that we could then interoperate with. So we're able to show SRT interoperation. We're able to also show OBS operation or anything that can work with NDI. We can then take the NDI and mirror that out to anything else. So as I sit on the sofa inside the studio talking to you guys, I'm able to actually see a feedback on the monitor in NDI, so I can check that everything's going out as I'd expect it to, and that I'm really broadcasting. We're also able to pick that up and retransmit that to the cloud. So it's exactly that same technology now running in reverse, taking the output of the OBS station, and again, we use a Synergy Air engine to record that, compress it to H.265, beam that up to our German data center, and distribute that so that you guys can actually see what you're watching in the studio. So we've demonstrated interoperability with NDI, the great open source product OBS. We're using Wowzer Cloud to actually transcode the material, and then we're using our own tools to catch things, record things, play things out. Of course, D2CAM is right at the center of all of this, and that's the heart of what we're talking about in here. So I talked a little bit before about why we like SRT and how it exposes a lot of metrics so that we can really drill into the detail of what's happening on our network link. Let's take a look at one of the dashboards that we've designed that picks up the output from the changes we've made in the latest version of Synergy Air that allows us to record and store in Elasticsearch all the details about our SRT transmissions and all the different client connections that have taken place into that engine. So if we look at this video here and this graph, we can see that we can drill right into the details of how that link is operating and how the ping time and round trip time is altering and what's happening to that link. Now, hopefully, not a lot bad is happening on here. And probably this graph is overkill for a lot of people. So at the top, we've got what are called single stat panels. And these are the things that can call out to you how hard the SRT engine is working, how many frames have been lost that have been recovered, and therefore nobody sees any problems, and how many frames have actually been dropped, how many packets have been dropped that would genuinely affect quality. So ideally, you'd tune up SRT to have enough time in that round trip time to repair any holes that have appeared in the network and fill that in. But of course, you don't know what's happening inside there without being able to drill into the metrics. This is a great enhancement to the latest Synergy Air engine, and one of the benefits of using SRT underneath D2CAM to transfer things, because we can see how healthy that network link is from the iPad to the receiver. We're not limiting ourselves to streaming from D2CAM either. In fact, the earliest versions of D2CAM didn't stream at all. They recorded straight into the iPad and into the iPhone that I was wandering around with, taking some videos in Bristol. It gives us the opportunity to really try and push the hardware in this great equipment to the limits. So we can then try and build some broadcast-centric modes that aren't available in the hardware codecs baked into these products and extend using our software Daniel 2 codec to add these things back in. So we've actually got modes in D2CAM that let us capture in 444 color space in HD that lets us then do better chroma keying and bring that in to really do stuff that's not possible with the built-in equipment on this device. It also gives us the ability to record a broadcast-centric 422 10-bit 1080i 50 interlaced picture, which is definitely not possible on these devices normally. And this can be really important if you're trying to snap them into existing broadcast workflows, and most workflows at the minute are still interlaced in HD. So having this software option has let us experiment with a lot of these things and produce these different modes that aren't possible normally on these devices, and give us a lot more flexibility. It also means that we can start to look at using recordings on these devices that can be stored and forwarded into broadcast workflows more easily. Perhaps you could be recording as a journalist in the field, and yes, it might take you longer to upload a D2 encoded piece of content, but you could actually be recording in a beautiful, smooth, interlaced 422 encoded package that's going to be much easier for editors at the far end to download and work with and integrate in. So it looks like you've got a full broadcast camera, perhaps, where you really just had a phone in your pocket. These are areas we're experimenting in at the minute. And of course, this is all very young and experimental. But we don't intend to stop there. What we'd like to do is hear a lot more from you guys about where you think this could go. Let's take a closer look at some of the quality comparisons I made when shooting video with an early version of D2CAM into files. We'll need to zoom in to highlight the differences, since unfortunately the very act of streaming this video will make it hard to compare otherwise. But what we've done is I've pulled some pictures from video I shot. You should be able to see the difference even through this compressed stream. So I just used the camera app on my phone and I set it to high quality and I recorded in UHD just some shots in my back garden. And you can see here this is a shot of my dog. So if we zoom right in here, then we very quickly start to see that there's very obvious compression problems, even in the high setting on this built-in app. And very quickly I was quite disheartened with how that looks. But at the same time, because of the settings on my phone, I haven't completely overwhelmed with my phone's internal memory, and I have videos in iCloud going back 10 years. So I can see why it's set to this mode. Let's now look at a much more sensible comparison. I recorded this with the Filmic Pro app in extreme mode. So this is as high as I can set the really great Filmic app on my phone to do recordings. And if we look, we can see the dog now looks much clearer. And if we zoom in, it's much harder to spot differences. And you might not be able to see the differences, but what you can see here, if you are able to see a good enough quality, is that it's a little bit soft and there are some artifacts. And what's not visible in a still is that because we're compressing with a long op, you do see some kind of temporal differences as time goes by and we're looking at high detail that's changing. Of course, one of the really difficult things I found when working with this clip is it's a real pain to edit and scrub through. It's still a lot smaller than a Daniel 2 file, but it was much more difficult to actually move around and edit with. So let's now look at a clip I filmed with the D2CAM in the high quality mode on here. So the sun came out as I was doing this, so now we have slightly different light conditions. But if we look, we can see a very pristine picture of the dog, and all the hair stands out more obviously. The sun helps a little. If we zoom in, we can see that actually we retain quite a lot of quality, and there's still an amount of noise visible in the picture that's come from the sensor that looks more natural. Maybe the detail's coming across here, maybe it's not. What we will do is we'll try and package up these actual bitmaps and put them out for you guys to look at post-event if you want in a link. Maybe some post-production fairies put some information on screen for you right now. But the detail that you can see here is much finer, and because every frame is an iframe, is very consistent between each frame. And when I came to edit these, even though the clip is much bigger than an H.264 compressed version from my iPad, when I wanted to scrub around, it was very, very easy to move around and edit. And once I loaded up the Adobe plugin to support Daniel 2 encoded files in Adobe Premiere, I was able to edit and work with this much more quickly and easily than I could with the H.264 extreme compressed version from Filmic. So editing workflows were better. But what I can do as well is I've pulled a still, again, from a complex scene. A day later, it snowed in Bristol. What I'll put up on screen now is just a still I picked from a running video. And it gives you a real idea of how much detail is in the picture still using this codec. So if I zoom right in on these berries here, we can see that there's actually still a great deal of detail in this still. You'd never believe it was pulled from a video. It's as if I snapped it still. We'll add that to the package of files that you can download. What we'll also try and do is actually get some of the video files uploaded for you as well, and provide a link, or maybe there'll be some notes in the comments, I don't know, that would allow you to actually access the original Daniel 2 encoded files as MXFs. And you can then look at those inside the free Synergy Player app, or any of the apps from Synergy that are up to date and support the Daniel 2 codec, or you can install the plugin for Adobe and look at them in there. So don't just take our word for it, do actually take a look at some of the files I recorded on an iPhone 11 Pro that really do look quite stunning and tremendous. So let's talk a little bit about delay. I'm network streaming from this iPad. How long does it take for this picture to get picked up from the iPad and delivered into downstream elements? The biggest problem I ever have with anyone that says to me, how much delay does it add, is it really depends where you're measuring things from. I could be looking at the results of this on the end of a chain that's done 2 more compressions, and that would add quite a lot more delay. I could be adding error correction because maybe I'm feeling a little paranoid and I'd like to make sure that if I have any problems on my network, I give the SRT library 100, 200 milliseconds of time to actually cover over that problem. If we have a spanning tree event on our network, maybe I'd like to have the time required for the network to recover and backfill that data. So I can add delay there, but I add it for a good reason. But maybe I trust my network, or maybe I've got some high quality switches that I don't let anyone plug things into while I'm broadcasting, and I can turn that off and set that to 0. So my delay could come down more. Similarly, the clocks inside an iPad aren't synced to any station genlock, so we have to be respectful of the fact that we do have some frame drift potentially between receiving devices and transmitting devices. But that's okay because I don't have to set up a really complicated PTP timing domain that would be able to correct that, but actually for a lot of use cases isn't going to add me much benefit. So what I can talk about is what's the fastest we've managed to get from glass to glass, the output of a D2CAM app onto a screen. We built some experimental apps to try and work out what the very lowest level of latency we could get would be if we took all of the safety handles off. And we found that we were able to get 80 milliseconds glass to glass. If we look at this picture here, we can see where we were experimenting, and we showed just 2 PAL frames of difference between what we were taking on the iPad and what we were then rendering back on the screen. So we knew that we could get some really quite responsive times from this. But then we did put back in, because we let the Air engine eat the stream, we put back in some more delay because that gives us buffering and stabilization and error correction time that keeps everything ticking smoothly. So the delay you might see is going to be something you can choose. You'll be able to set parameters on the receiver to say how much time do you want to make sure the signal is stabilized on the receiver, how much do you trust the receiving device, and how well is your network card configured. And also you'll be able to control delay on the D2CAM app, indicating how much time you'd like to be added into the SRT protection string. So where do we go from here? This is where you, our audience, really come in, because we built this prototype and we've used it and we've had a lot of fun with it. But we'd like to hear from you about where we should take this next. Are you guys more interested in the studio streaming aspects of this, where you can use an iPad or potentially an iPhone, although the problem with the iPhone is it doesn't have USB-C to transfer at really high nice bit rates. So you could use these devices inside studios and inside remote locations where you just can't quite get a full studio camera, for example, and bring that in as an alternative to kind of a full-fledged NDI camera, perhaps. And maybe that's something that's really interesting to you. Maybe you're more interested in being able to do the onboard recording workflows, where perhaps you're interested in using it to generate broadcast-oriented outputs with interlaced signals ready to snap into broadcast workflows. And you'd like us to put some effort into making store and forward workflows that allow journalists to upload videos really simply. Or maybe you're interested in the higher end of recording straight onto the iPad. So you're interested in working in UHD, and you'd like to try and push the 10-bit boundaries and see what we can do with higher color depth, and to get the really high quality that we can do that already exceeds what you're able to get from Filmic Pro with its extreme modes, but that's limited by the hardware on board. What would happen if we took that further forwards to get a better quality recording and maybe focused on that side? So what I'd like to do is invite you guys to tell us more. We already have an internal beta of this app running up in the Apple Store, so we can distribute this internally. But we'd like to know where we should go next and who might be interested in looking at this. So your feedback's really crucial. And in a moment, you'll be hearing from me again on the other side, sitting on the sofa in our office, answering your questions. So please do think about the questions you might like to put to me, but don't be afraid of what you might ask for, because we don't really know where we'll necessarily go with this, and we'd like to hear from you more. But what we do know is we're going somewhere with it, because we've had a huge amount of fun working with it. So I'd like to thank you all for listening to me as I've presented through this. Hopefully I've answered most of the questions you might have had about how we built this technical conference and how we filmed it using this innovative new app. But if I've missed anything, hopefully you'll be asking me in just a moment. Thanks very much.